Why is everything around us the way that it is? Answering this question seems like it would take a number of concepts to explain, but really, every interaction that takes place in our universe boils down to one of four fundamental forces. Let's start with the one you've probably heard of, gravity. This is the mutual attraction between two objects. According to Einstein, masses cause distortions in spacetime which attract other masses. It's the weakest of the four forces, but its range is infinite, which is why it can act all the way in space to hold the Sun in place in the Milky Way, the Earth to the Sun, and us to the Earth. Just like gravity, the next force has an infinite range. However, it's the second strongest force. Electromagnetism attracts and repels charged particles. It depends on its force carriers, just like all the other forces except gravity do, which is a photon. Think of it like two people in separate boats throwing stuff to each other. If they face each other and throw a ball, they move away from each other, like particles with the same charge would if a photon moved like the ball. If they face away from each other and throw a boomerang, they go towards each other, like oppositely charged particles would if a photon moved like the boomerang. We see electromagnetism in everyday things, but the important thing to remember about it is that it attracts electrons to the nucleus to form atoms, which make up everything around us. The weak force is weaker than electromagnetism, but is actually stronger than gravity despite only acting on the scale of the atomic nucleus. It changes quarks, which make up protons and neutrons, from one flavor, either up or down, to the other through contact with the force carriers W and Z bosons. This transforms the protons and neutrons into completely new particles, which is why we have radioactive decay, as well as the nuclear fusion that fuels the sun. The fourth and final force is a strong force. Although it has the shortest range, it's the strongest force because it holds protons and neutrons together in the nucleus and quarks together in the protons and neutrons. The force carrier is a gluon, and it acts as a spring between quarks, immediately pulling one back if it strays too far from the others. This process has so much energy that some of it, called the residual strong force, works outside of the protons and neutrons to hold the nucleus together. Without the strong force, we wouldn't be able to hold protons and the nucleus together, and the only element to exist in our universe would be hydrogen. With all that explaining, it might seem like the makeup of our universe is completely understood. However, there's still a lot of progress to be made. Today, a big goal in the field of physics is to connect all four forces through a single equation so we can explain all the phenomena observed in the world with just four principles.